Hello there, welcome to CXC Math TV. Today we're going through the June 2022 paper one for Pure Math Unit 1 and we want to just get into it. Just felt like doing some maths for fun. So I'm going to give us all the Pure Math paper 1 2022. So number one, repeat question. By the way, any repeat question, just going to circle it. And of course, we'll work out the new questions that came this year. This is a repeat from previous years. So make sure you're doing at least 10 years of past paper from 2013 coming up. Number two, that's a repeat. That statement is a tautology. This one also repeat from the 2020 paper. Check the 2020 paper. See here on the channel, go check it out. Just to check if they don't make any change to the question. It is raining P and the sun is shining Q, and it's supposed to be not R and not R, but there is no rain. Yeah, so they didn't change it. So again, that is C. Alright, so those are three repeat questions. Question like this, I think it repeats, but anytime you're not sure and it's a third question, put it in your calculator. You have no worries to put it in your calculator. That's always going to be beneficial. So just put in our calculator, 7 root 5, that's it. This one is a repeat question as well, D. And if you don't believe it, if you have a number, x is less than y, like negative 3 is less than, let's say, 4. But we know that negative 3 minus 4, then you take the modulus of it, that will be greater than 0. So D is the answer. Number 6 is a repeat, C. Alright. So far, lots of repeat. Number 7, log, this right here, they say log base A of 16 equal 5, and we need to find log base 2 of A. I remember the answer is 4 over 5. Yeah, this is a repeat. Alright, so we're not even bother gonna do it. That's a repeat. Alright. Now this question now, is like a repeat, but can't remember it, so we'll work out this one. Now, it says P of alpha equals 0. What are the values of h in terms of alpha? So we're trying to find h. P of alpha equals 0 mean we're saying alpha square minus h times alpha minus 12h square equals 0. Bring everything to the other side. So 12h square minus, well, bring it over, it become plus h alpha, and bring it over, it become minus alpha square, that is 0. So from that, if we're solving for h, that means a equal 12, b equal h, and c equal minus alpha square. So the quadratic formula now, h is going to be minus b, so negative, sorry, b is alpha. Remember, h is the variable. So b is alpha, h is like a x now. So remember the quadratic formula, it's minus b plus or minus the square root of b squared minus 4ac divided by 2a. And so h is going to be minus b, so minus alpha plus or minus the square root of b squared, so that's alpha squared minus 4 times a times c, so 4 times 12 times minus alpha squared. And then we're going to divide it by 2 times a, so 2 times 12. So h is equal to minus alpha plus or minus the square root of 4 times 12, and then times negative alpha square, that's 48 alpha square plus alpha square is 49 alpha square over 24. So that means h is equal to negative alpha. When you square root, you get square root 49, you get 7 alpha over 24 minus alpha plus 7 alpha is 6 alpha. So h is equal to 6 alpha over 24 is alpha over 4. And the next answer is minus 8 alpha over 24, which is minus alpha over 3. So we get the two answers. It's option A. I'm almost certain it's a repeat, but could remember the answer. This question, if the range of f of x is this, if they give you the range, what's the domain? Now, if you What's the domain? If you notice, these are what we call the y values. I'm trying to find the corresponding x value. So if you set 2 over x plus 1 equal to, let's use 5. I like to start with the n value, 5. Bring it over, so 2 over x equals, subtract 1 from both sides, that's 4. And then we interchange um, x and 4, so that means 2 over 4 equal x. So one answer is x equal half. Now, half, only two options have half, so it could either be A or C. So now let's look at when it's equal to 3. So 2 over x plus 1 equal to 3. So 2 over x is equal to 2. So x must be 1. So far we have 1 and 2. Now do it one more time. 2 over x plus 1 equal 2. So 2 over x equal 1. Interchange, so x equal 2 over 1 is 2. So suppose to have 1, 2, and 1, 2, and 4, and also half. So half, 1, 2, and 4. That's clearly option C. Alright, so basically we're finding the domain in this question easy. Number 10, this is the function, find the inverse. Remember, function, you call it y. Y is 3 to the x. Find the inverse, you interchange x and y. So 3 to the y. Then make back y the subject, so we log both sides. So log x equal log 3 to the y. And bring down the power y. So y log 3 equal log x. And then we just divide both sides now by log 3. Divide by log 3. This cancels, so that is y. So the inverse of x is just log x divided by the log of 3. A. No worries. This question, A, this look like the graph of y equal 3x. So option A, oh, that's a straight line graph. This look like the graph of y equal 3 over x. This look like the graph of y equal x squared. So here it is. Modulus, you reflect the part of the graph that's below the x-axis, above the x-axis. That's for the modulus symbol. Easy. So number 11, D. Alright, this question here, it want the range of f of x. This is a quadratic graph. So remember, this is how the quadratic graph look. Something like this. Something like this. And they want the range of values for y. The range of values of y is always the y value at the turning point. So k. And the formula we learn for k is 4ac minus b squared over 4a. So that is 4 times 1 times 6 minus negative 5 squared over 4 times 1. And then you put that in the calculator. Or you could go ahead and complete the square by factorization. I'll put it in the calculator and we'll get negative quarter. So y is greater than or equal to negative a quarter, because that's what we're getting. Negative a quarter. That's the y value. Number 13 has been repeating since forever. We know this is the 3 over 2. Alright, so that's a repeat question. X plus 1, x plus 2. The next one was 2x minus 3. That's been repeating forever. Repeat. Number 16 has been repeating forever. I think this is pi by 3. This has been repeating forever. Alright, they always bring back that question. And if you don't believe it, you can check it in a calculator. 2 times the cosine of 60 degrees. And remember, cos 60, we need to square it. That is showing you that the answer is indeed correct. Plus 3 times the cos of 60 minus 2 get 0. So no, 60 degrees, right? That's been repeating forever. This one has been repeating forever. We know it is A. That one's been repeating forever. Um, that's number 14. Number 15, another repeat, minimum value minus r, this one. So just to write those that repeat from previous years. Repeat, repeat. Number 15, it says find intervals for which the domain of f of x will lie. We can't square root a negative number. Remember, anytime you see square root x, x have to be bigger than 0. So automatically a out. Automatically 3 out. Only one possibility, 2. Once it's a square root, alright? And then, of course, we need to talk about the discontinuity in the denominator, but 2 is all you really need to know. Number 17, I know this is a repeat, but I can't remember it, so we'll work it. Cos to the fourth power is cos square minus sine to the fourth power is sine square. So this is now 1 plus, this is now in bracket. Remember a square minus b square is the difference of 2 square. That's cos square a minus sine square a. And then this is being multiplied by cos square a plus sine square a. So in that case, we have 1 plus cos square a minus sine square a is cos 2a, and then this is times 1. So sine square plus cos square is 1. But then now, cos 2a, remember, is 2 cos square a minus 1. Then 1 and the minus 1 cancel. So we get 2 cos square a. So 2 cos square a is option D. This is a repeat question, number 19. We're looking for arctan 3. This is B. This is A. 1 tan inverse of 3. Option A. That's another repeat question. Alright. Now, number 20, this one right here. We need to see what this simplify to be. What can we do? I'll convert this as sine square x minus cos square x over. Now tan square, we have to remember tan square is sine square x over cos square x. Then remember the number 1 can be written as cos square x over cos square x. That is 1. So what we're getting is sine square x minus cos square x, and it's being divided by, this is now sine square x minus cos square x over cos square x. Now when you're doing division, you can always change the sign from division to multiplication and flip it. So it's sine square x minus cos square x over times cos square x over sine square x minus cos square x. Then in this case now, these two cancel each other. And so we have 1 times cos square, which is cos square x, which is option B. This part, I want vector PQ. Vector PQ. So vector PQ is equal to OQ minus OP. So we subtract minus 1, 4, 4, minus 2, minus 1, 8. That's giving us minus 1 minus 2 is minus 3. 4 minus 1 is 5. And then this is negative 4. And I want the magnitude of PQ. So the magnitude is negative 3 square plus 5 square plus negative 4 square. And then we square root it. That's 9 plus 25 plus 16. That's square root 50. And you put that in a calculator, that's 5 root 2. Check if anymore. 22. I know this repeat, but I can't remember the answer. I know this repeat. Now make sure when you're swatting, you remember the answer. Sometimes it's kind of difficult. It's kind of tricky. Be careful. So the y coordinates. So to find the y coordinates, let's make x the subject here. X is equal to, bring it over, this is y squared minus 7. Plug that right here. So So this is now y squared minus 7 times y equal to 6. This is now y cubed minus 6y minus 7y minus 6 equals 0. Now use trial and error. Now first thing, C and D out. This don't make any sense. So let's just look at these one right here. I'm going to try -2. Well, since -2 is in both of them, I'll try -1. So I know it's either A or B. So let's try -1 to see if it satisfies the equation. So -1 cube minus 7 times -1 minus 6. We get 0, so clearly -1 work. So our answer is A. We know 2 gonna work, -2 gonna work, and we know 3 gonna work. If you factorize it, it's actually y plus 2, y plus 1, y minus 3 equals 0. So we're good to go. A is the answer. Alright, so this question now it says a curve has that equation, the equation of the tangent to the curve. Now, to do this question, first thing we have to notice is this is how can I put it? This is a calculus question. So what you're gonna have to do, you're gonna have to differentiate. You have to differentiate. So in this case now, we're gonna differentiate both sides. So when you differentiate x cubed, you get 3x squared. Then now we're going to differentiate 4xy as a product using what we call implicit differentiation. Right? You need to know implicit if you're doing pure math. Alright, it's just the truth. So this is now keep the first times the derivative of the second. When you differentiate y, you get dy dx. Plus keep the second y times the derivative of the first 4x, which is 4. Plus when you differentiate y cubed, you get 3y squared dy dx. And that's equal to 0. Now we just need to transpose that equation, make dy dx a subject, and that's going to give us the gradient of the tangent. So by the way, this looks like a lot of work, so I'm actually going to substitute in the points 0 and -3. So when I plug the x value as 0 and the y value as -3, this is saying 0 minus anything times 0 is 0. Then I put the y value as -3, so that's plus 4 times -3 plus 3 times the y value -3 times dy dx, and that's equal to 0. So in that case now I transpose it. 4 times -3 is -12, and this is now 3 times -3 is -9 dy dx equals 0. So that means dy dx times 9 is equal to, bring over that's -12, divide through by 9, so dy by dx is -12 over 9, which is, put that in the calculator, -12 divided by 9 is -4. Well, I get -4 over 3, so I probably made a mistake somewhere, because none of these are 4 over 3. So 0 is here, keep the first, differentiate the second, plus keep the second, y, differentiate the first 4. I inputted 4 and -3, that's -12. This part is 0, this part is 0. Differentiated 3y cubed, so 3 times. Oh, I left off the square here, guys. I left off the square. -3 when I square it is 9. 9 times 3 is 27. So pay attention there. So plus 27 dy dx. I bring it over. So when I bring it over, it would become 27 dy dx equal positive 12. And so I divide, so that is 12 over 27. And then you put 12 over 27 into your calculator. So 12 divided by 27 is 4 over 9. So I'm looking for a question with 4 over 9 as the gradient. And also the y-intercept is -3, so B. So remember, this is gradient of the tangent. Then remember the equation of a line. Once you have the gradient of the tangent, remember, gradient of the tangent, once you have it's 4 over 9, then y equal mx plus c. We already know c was the point. Remember, they gave us the point 0 minus 3, so c is negative 3. So y would be 4 over 9x minus 3. So that's why we have that. Nice. 24 is a big repeat question. It's option D. Is a repeat. Anywhere we see repeat, we don't work it out. Don't work out repeat questions. This is a repeat question from previous years. This one was 0. Remember, you draw a circle, center minus 2, 0. And then you have the point 0, 0 is here. And they want the equation of the gradient of the normal, the gradient of this horizontal line. So this is a repeat question. Now 26 is also a repeat question, but can't remember what the answer is, so we'll work it out. X squared plus y squared minus 2x minus 6y plus 1 equals 0. And we have x squared plus y squared minus 8x minus 8y plus 31 equals 0. And then we go ahead and we subtract them. X squared is gone. Minus and minus become plus 6x minus 6y minus 8y, that become plus 2y. And 1 minus 31 is minus 30 equals 0. Divide through by 2, that's 3x plus y minus 15 equals 0. That's it. 3x plus y minus 15 equals 0. Make sure I circle the right one. Yes, that's C. Number 27, the vector equation of a line. Remember, R equal A plus TB, where A is the known point. The known point is, see it here, 2I. Remember, this is saying 2I plus 0j minus 6k. So we're looking for that. 2I plus 0j minus 6k. Here it is. Option B. 2I, negative 2I. Well, it's positive. The point is positive 2I, so don't circle the wrong one. 2I and minus 6d. Here it is. Ooh, almost made a mistake there. Now 28. This one is a big repeat from previous years. I think it's this one. K is less than negative 6. K is less than negative 6 and K is greater than 2. So this is a repeat one. Alright, check it back. That's it. Alright, 29 also a repeat. Alright, so this was 1 over 13 here. 1 over 13, 5i plus 12j. Repeat question. Number 31 I know is a repeat. So once you see repeat, you just put the answer. Now this one now, never seen this before from previous years, so we'll work this one out. To find the angle between two vectors, first you need the dot product. So u dot v would be 4 times 3 is 12 plus negative 5 times 6 is minus 30 plus 1 times minus 1 is minus 1. Work that out. That is 12 minus 30 minus 1. I think that's negative 19. So the angle between them, remember theta is cos inverse the dot product negative 90 over the magnitude. The magnitude is square root 4 square plus 5 square plus 1 square square root. That's 16 and 25 and 1. That's 42. Then this one is 3 square is 9, 6 square is 36, 1 square is 1. This is 46. Now put this in the calculator. So cos inverse negative 19 over square root 42 times 46. Put in the calculator. And we have 115.61 degrees. Option A. Number 32, when you differentiate tan, you get sec square. So I think that one was fairly obvious. There it is, we differentiate tan, we get sec square. Ignore this page, please. I didn't scan it properly. This is the page we look at. I know number 34 is a repeat. Alright, so once you see that it's a repeat, I remember it's 12x cubed, this one, repeat, from previous years. Now we need to differentiate this twice. First derivative would be 12x squared. When you differentiate sign, you get cos. 6 times 3, 18, so that's minus 18. Differentiate sign, we get cos 6x. Then the second derivative now is going to be 24x, and the differentiate cos, you get negative sign plus 108 sine 6x. So 108 sine 6x, that looks like option D. Number 35, we're going to use L'Hopital's rule. Differentiate the numerator, that's 2x minus 2. Differentiate the denominator, that's 2x minus 5. Plug in negative 4 now. 2 times negative 4 minus 5 over 2 times negative 4 minus 5. Numerator was 2, I mean. So this is now negative 10 over negative 13. Negatives cancel, 10 over 13. This one now. The volume of a solid when the area about the y-axis. First thing, volume about the y-axis is pi times the integral from a to b of x squared dy. So volume about the y-axis equal x squared, they say is y. So it's pi times the integral from 0 to 4 of, because it says it starts at the y-axis, of y dy. When we integrate y, we get y squared over 2 going from 0 to 4. Then the result we're going to multiply by pi. Plug in the 4, so we get pi times, this is now 4 square over 2. 4 square is 16. 16 divided by 2 is 8. That's 8 pi a. Not bad at all. Where is the function discontinuous for 40? Set the denominator equals 0. If the denominator is 0, that's when it's undefined. You cannot have 3 over 0. That means when x is negative 5 or when x is minus 3. This one is a big repeat question. Remember, it's one with plus. So it's D. Alright, that's been coming forever. Now these two, my gosh, we need more space to do this. Let me plug in the computer before the battery dies. Alright, so then say a curve is defined by this parametric equation. X equal 4 sine theta, y equal cos theta. So the first thing we have to remember is sine square theta plus cos square theta is equal to 1. So sine theta would be divided by 4, that's x over 4. So x over 4 when you square it plus cos square theta, divide both sides by 3. So cos theta is y over 3, so y over 3 squared equal 1. This is now x squared over 16 plus y squared over 9 equal 1. Multiply through by 144, which is the LCM. 144 over 16 is 9x squared plus 144 over 9 is 16y squared equal 144. That's option C. Alright, let me see. When you integrate cot, when you differentiate cot, I mean, when you differentiate tan, there's a rule, there's a rule. When you differentiate tan, notice we did it around here. This question, there's a rule to remember. When you differentiate tan ax, you differentiate tan, you get sec squared ax times a. So now the rule is when you differentiate cot ax. When you differentiate cot, you get the next one to sec, which is cosec. This is cosec square ax times a. So when you differentiate cot, you get cosec square. So looking for cosec square, when you differentiate cot, you get cosec square minus cosec square. That should be as well. And I forgot the minus here. So minus cosec square. So when we differentiate cot, we get minus cosec square. Then we'll multiply by the derivative in the bracket, which is 2. That's option A. Yeah. This one is a repeat. They want the gradient of the normal at 2. But I don't remember the answer, so might as well work it out. Y is ln x. So dy dx is 1 over x. Then put in the 2. 1 over 2 is the gradient. And so that's the gradient of the tangent. So the gradient of the normal is negative 1 over the gradient of the tangent, which is negative 2. That's option A. Number 42 is a repeat. This one was the negative 20. Number 45. This one is also a repeat. But let's just find dy dx equal 6x minus 2. Plug in the 1. 6 times 1 minus 2 is 4. That's gradient of the tangent. And so the gradient of the normal is minus 1 over 4. Normal I want. So we just have 2 more to do. The portion of the curve y equal 2x between a and b. Volume about the x-axis. So volume about x-axis, remember it's pi times the integral from a to b of y squared dx. So the volume is going to be pi times the integral from a to b. Y is 2x, then we're squaring that dx. When you square 2, you get 4. So volume is now 2 squared is 4. So that's pi times the integral from a to b of 4x squared dx. We can factor out the constant. That's 4 pi times the integral from a to b of x squared dx. So we're looking for 4 pi x squared. So pi x squared times 4. I'm looking for dx. So anything with dy out. So here it is, d. Alright, so hard to find. Number 44. Differentiating cos cube. That is, they don't even give us any space to do this. So CXC need to give more space to that last one. We have f of x is equal to cos cube 3x squared minus 1. And now f prime of x, we just need to differentiate this. So remember, we're going to have to rewrite this as cos 3x squared minus 1. This is being all cubed. So then now f prime of x is carry down the power 3. You subtract 1 from the power 2. Then you multiply by the derivative of cos. Notice this is inside the bracket. Imagine you use chain rule and said it was u cubed. You'd have to multiply it by du, don't? So that's all. So in that case now we multiply by the derivative of cos, which is sine, but negative sine rather, negative sine 3x squared minus 1. Then you have to multiply it by the derivative of what's in the bracket, and the derivative of 3x squared is 6x. So that's a whole heap of work. 3 times minus 1 times 6, that's negative 18x. Cos squared 3x squared minus 1 times sine 3x squared minus 1. That's the answer. So we're looking for negative 18x. So A and B out already. Then we're looking for cos squared. Here it is, D. So that's it. So we pretty much finished the paper. Quick and no time. If you do enough papers, you can finish fast. Alright, so I wish you all the best getting ready for paper 1. Alright, stay tuned.